that was the first chapter that was started in your school, Pawan, right?
Yes, sir.
Okay, it still hasn't been completed. Okay. Okay. For how long has it been going? Like for how many classes did the teacher took? Yes, Pawan?
About less than 2 weeks.
Less than 2 weeks. Okay. So that is more than 10 classes for that chapter, right?
Yes.
Okay. So, Ross, what about you?
So for me, the first chapter has been finished. The
Okay.
previous chapter, uh,
And
and we did force and pressure. We completed that, and in chemistry, we did synthetic fibers.
so in your school, was force and pressure has been done.
Yes, sir.
Okay. Crop production also has been done.
Yes, sir.
Okay. And in chemistry, what did you told?
Synthetic fibers.
Synthetic fibers and plastics. Going on, or like has it been completed?
So completed.
Completed. Okay. Okay. All right. By the way, you guys have got the final syllabus. Like, what are the chapters that will be taught in your school throughout the year, throughout the curriculum, right? That thing is for sure confirmed now. If you were to remember in the previous class, not in the previous class, but I did told you about the list of the chapters. Okay, that is there in the syllabus. Some of the chapters, like synthetic fibers, metals, and non-metals, such chapters were removed, but in some of your school, like in some students, it is still being taught. Okay, you tell me about this, Pawan. Synthetic fiber and plastic, is it there in your syllabus?
I don't think so, sir.
Okay, you're not entirely sure about it though.
Yes,
Okay,
I'm not entirely sure.
okay. Try to get an update on this chapter from the teacher. Okay, now, Pawan.
Okay.
Was any idea about materials, metals, and non-metal? Is it going to be part of the syllabus or not?
So it is in my textbook, but I don't know if they'll teach it or just skip it all.
Okay, you have the latest textbook, or are you using some old textbook?
Uh, yeah, it's a old textbook like NCRT 2023, I think.
Oh, okay, then that's a different thing. Okay, no, like the new version is most reliable. Okay. Microorganism has not been started in any of your schools, right?
No, sir.
Okay. So if microorganism hasn't been started, so most likely I don't think it is going to be upcoming in your PT exams then. Okay, it won't be coming, I guess. Synthetic fiber has been completed in your school was, but Pawan, you don't have any idea whether it's going to be part of syllabus or not. Okay, let me see which chapter we can begin with then. Who else is absent today? Fatima hasn't joined yet, no? No. I need to get update from her as well. Okay, in the meanwhile, let her come. Meanwhile, what we will do, there were a few questions, I guess, that were still left from this chapter, crop production. All right. So we will discuss that. Let her join and I will get the final idea once I talk to her as well. Okay. Yeah. So match the column. Let's do this one. I'm going to assign the questions. Okay, now the first three you do, Pawan, and the last two was you do. Okay.
Sir, should I tell it to you?
Hold on. Yeah, just tell it to me.
Okay. Grana, granary,
Mm-hmm.
I mean,
Granaries.
groundnut. Yeah,
No.
granaries.
Mm-hmm. No. No.
Groundnut, I
No.
think.
No. 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 Go through the options once again. Look carefully. There's no need to hurry.
Sir, silos?
Silos. Okay, na? There are two
Yes,
types
sir.
of granaries, right? One is the silos. One basically we had the like silos or what? They are basically grain silos. Basically the place where we store the food grains into large, tall, cylindrical containers, right? So they are basically
Yes, sir.
granaries. So first it
Yes,
is
sir.
fourth one good.
Kharif crops are paddy and maize. Fifth one.
Paddy and maize. Okay. Okay.
The third one, we decide is 2,4-D.
Hmm. 240. Very good. So for the second one, kharif crop, paddy and maize. Okay, and we decide you have also answered. Very good. That is 240. Can you guys give few more examples of VD sites like the one which we have discussed in the class? Remember 2,4-D, you had MCPA also, butachelor, right? These were some of the common VD sites. Yes, Gauss.
So for the fourth one, Heckley.
They clean good. And last one,
Fertilizers, NPK.
obviously NPK. Good. Okay, you guys give few more examples of the fertilizers.
So superphosphate, urea.
Superphosphate, ammonium sulfate, urea. Good. Okay. Okay, few more questions are left. You guys answer it here. Just go through the questions. Let me text whether she'll be joining or not. Give me a minute.
So we answered in the chat.
No, start answering. I have texted.
The first one is true.
Okay.
Manure consists of organic matter.
Hmm.
Second one, true.
Good. Then Pavan.
But
Third
the
one.
third one is false.
Hmm. What is the function of combine? Yeah.
Mm,
Okay, she won't be
For
joining today. Yeah.
the harvesting, threshing, winnowing.
Hmm. Different multiple tasks can be performed by this in one go. Good. Next. Yes, goes. Next one. Fourth one.
So is it like asking agricultural practices?
Yeah. Basically, agricultural task or practice, same thing.
So false.
Obviously. So, what would be the correct thing? Correct statement.
preparation of soil.
Exactly. That one is false. Next.
Fifth one, true.
Obviously, it saves lots of water. Next.
So false.
Obviously not. So what are
False.
some other criterias? Huh? What are some other criterias to take care of?
Sir, ensuring that the soil is fertile and
Hmm.
you water the seeds properly and
Two more things are there. Two, three points are more to be added in this.
you add fertilizers,
Manures, okay,
manures.
Manures.
and proper seeds should be sown at proper spacings and proper depth, right?
Yes, sir.
Okay.
Yes, sir.
In a way, that is also related to this. Okay. So this is false. Next one.
False. Sir, is the second one false?
It is going to be false because when we grow different crops in different seasons in the same field, no, it is not going to deplete the soil of nutrients. Here, particularly, the question is saying in context of leguminous and non-leguminous crops, right? Now, so when we are growing these different crops in different seasons, so the leguminous crop will add nutrients to the soil. Which nutrient will be added?
Nitrogen,
Nitrogen by the bacteria known as
rhizobium.
rhizobium. Very good. All crop plants are sown as seeds in the field. Is the third statement true?
Sir, true.
How is it true? It's saying all crop plants are sown as seeds in the field. They are directly being
False.
false, no?
False.
So what example do
Because
we have?
because sometimes from the nurseries we take the plants, we do not take the seeds, like half grown plants, we take them and
Transplant
like
them.
put them in a pot. Yeah.
Hmm, very good, right? So in the case of so many plants, like some, uh, we have the examples of flowering plants. We have the examples of fruits, certain type of vegetables. Particularly the example of paddy. So first, they are grown in a nursery. They grow into saplings, tiny seedlings, and then we transplant them into the main field. So thereby it is false. Next, we have learned about leguminous plants, like for example, pea. Pea is a leguminous plant, right? And what we know about the pea, that its root has got nodules in it, right? Its root has that swollen structure called as nodules. So the question is saying that cells of root nodules of leguminous plants fixes nitrogen. Is it correct? Is it that the cell of the root nodule fixes the nitrogen into the soil?
No, sir. It's rhizobium bacteria
Ex-
inside.
exactly. It's
Yeah.
not the cell, but rather the rhizobium bacteria that are living inside this. Okay, na? That does the work of fixing the nitrogen from atmosphere and convert this into nitrates that the plant can now absorb. Plants cannot directly take it from the atmosphere. So it has to be converted into compounds of nitrogen like nitrates. Okay, this is one is false. Last one, and that is freshly harvested grains must be dried before storing.
True.
Obviously, true, no, because moisture will allow the growth of fungus, will allow the growth
Yeah.
of microorganisms.
It will
Okay,
spoil the grains.
exactly. Okay, so when we have to store the grains in bulk quantity, so we have to use chemical tablets to store the grains in bulk quantity. Getting it? Also, people in the villages, particularly, they usually use the traditional methods, like they will use neem leaves. Okay, na neem leaves have antibacterial properties. Okay, a few days ago, I was watching a video. There, what I saw that along with the neem leaves, they were putting the match boxes. There was this container. In this container, they had put the neem leaves. Okay, along with that, they have put matchsticks on this also, match boxes also. So now you might wonder, like, what does the matchbox has got to do with the prevention of the food grains from microorganisms, huh? Or moisture? Getting what I'm trying to say? So matchboxes contains chemicals in it, right? Matchboxes contains chemicals in it, isn't it? Particularly like on the sides of the matchboxes, we see the chemicals are present on it. Which chemical particularly? Red phosphorus is present in it. Red phosphorus. So red phosphorus, it prevents the growth of the microorganisms in it. Getting it up? So that was kind of an unusual thing to know, but yep, people have got various traditional methods that they follow. So that was all there in this chapter. So today, what we can do now then, Pawan, as you told me in your school, metal and non-metal has been going for the past 2 weeks, right? And in your school, was 3 chapters already have been finished: force and pressure, crop production, and then synthetic fibers. Hold on, you guys give me 1 minute. Okay. Okay, I don't have much option right now because I need to know what chapters are there in Fatima's syllabus. Okay, you guys will do one thing now. When you go to the school next day, so please ask your teacher to provide list of the final syllabus, like the chapters that are going to be taught in this curriculum. Particularly, Gauss, you will ask your teacher whether the chapter metals and non-metal is going to be there in the syllabus or not. Okay. Along with that, there are a few other chapters also. Just do one thing, just get a final list of the chapter names from your teacher. Will it be possible, Gauss?
Yes, sir.
Okay. Pavan, you will also do the same thing. Okay, na?
Okay, sir. Sir,
Like, like it's been.
sir, I think we're following like the old textbook with 17 chapters. I
Okay.
think,
I
but
think so. Hmm.
but some of them will probably be excluded, sir.
Some of them are not going to be in the syllabus, no? Okay. But it's better
Sir, 1 minute, sir.
to.
I'll come.
Okay, but it's better to get the final syllabus from the teacher. All right. In total, there are 18 chapters. Okay, in total, there are 18 chapters. So, was particularly you will do one thing, you will just take the screenshot of this first of all. Take a screenshot of this.
Okay, sir.
So, you will be asking your teacher whether these chapters, synthetic fibers and plastics, like this one has already been completed, materials, metals, or non metals, cell structure and function, stars in the solar system, and this chapter, pollution of air and water. Will it be there in the syllabus or not? Kindly try to get a confirmation regarding this. Okay, now.
Okay, sir.
As of now, I'm thinking what chapter should we start then? Like microorganism hasn't been started in neither
Sir,
of your school. Yeah, Pavan.
sir, could you please tell what is the seventh chapter in the textbook?
Seventh chapter. Is it reaching the age of adolescence?
I think so, sir. Sir, we don't have this synthetic fibers and that chapter. We don't have it, sir.
Okay, you don't have it. Okay. You sure about it, no?
Yes, sir. We wrote the syllabus the other day.
Oh, okay, okay. Tell me, and what other chapters have been removed? Tell me.
I don't know the remote chapters. Can I tell you the all the chapters names, sir?
Yeah, tell me quickly.
Force and pressure,
Hmm?
coal and petroleum, microorganisms, friend and foe,
Hmm?
crop production and management, conservation of plants and animals, metals and non-metals, chemical effects of electrical current, uh, mm, friction, combustion and flame, sound, light, and the chapter 7, reaching the age of that chapter,
Adolescence. Re-
adolescence.
okay, what about reproduction in animal?
Um, oh yes, sir, we also have that. And cell structure and its functions, some natural phenomena. Yeah, those two.
Okay, these chapters are the new syllabus. Okay, okay. We will start a new chapter soon, but it is very important to get these things cleared. Okay, now so it's taking a little bit of time, but it is important that these things gets cleared. Okay, now guys,
Yes, sir.
and Pawan, let me just click pictures of it. I will note it down later. Yeah. So as of now, what we can do, I was thinking to continue with synthetic fiber and plastic, but it is not in new syllabus. Metals and non-metals. Regarding this chapter, you are not confirmed. was, right? And in your
Yes.
school, this chapter has been going on for quite some time. Okay, let's start with this chapter as of now. Okay, as of now, we are starting with this. And since only some of you will be having this chapter, so maybe we'll try to wrap it up soon. Although, in that time, we will be discussing all the important things in the chapter. Okay. Once I get insight from all the students, then I will decide which chapter has to be continued. As of now, we are continuing with metals and non-metals. You guys okay with this?
Yes, sir.
Okay. Okay, let's start the class. Okay, Pawan. So this chapter has been going on in your school. All right. Now, in the chapter metals and non-metals, broadly looking at the objects that we see around us, we can categorize them into metals and non-metals. Most of the objects that we see around us. Huh? So we will learn what are the metals, what are their properties, what are their physical properties, what are their chemical properties. We will learn about the non-metals, right? What are their physical and chemical properties? What are their some examples? How do they react with different substances, or do they even react with different substances or not? We also have one more thing called as metalloids. Okay, na? So what are metalloids? We'll learn a little bit about that also. Further, in the physical property of metals, we generally know that when objects like objects made up of iron or steel or like copper, when they are hit, they produces a sound. They are generally strong. They can be heated and drawn into wires. They can be beaten into sheets. Further, we also see that certain type of metals, for example iron, it is very reactive, like it reacts with air and water, thereby a layer of rust develops on it. It reacts with oxygen, it reacts with water, it even reacts with acids and bases also. Most of the metals reacts with these things which I have mentioned. They react with oxygen, water, acids, bases. We'll look at the same type of reactions in the case of non-metals also. Like, do they also react with the different things like oxygen, air, water, acids, and bases, etc. Such things you will learn. Then we will also learn about the utilization of different types of reactions that occurs in nature in regard to metals and non-metals. Getting it? So these are the general things which we are going to begin with. But in the very first thing we are going to learn a little bit about like what is an element? What is an element? Okay, now. So first take a look at this table. Anyone know what do we call this? This is
Periodic table.
exactly. So right here we are having a periodic table. See, the very first thing we're going to understand is about a element, about an element, like in what is a element basically. So a substance which cannot be broken down into two or more simpler substance by the chemical reaction, that is called an element. What do I mean to say? Say for example, out of all the different elements from this periodic table, let us take iron. This right here is iron. Fe is the symbol of iron. Now, if you have an iron element, if you have iron element, so iron element cannot be broken down into two or more simpler substances by the usual method of carrying out chemical reaction, such as if I were to heat this, if I were to flash light on it, if I were to pass electricity through this iron element, so it is not going to break into two or more simpler substances. Huh? So we are saying that is like these elements are the simplest substances that we can have. They do not contain anything else in it. Say, for example, if I have to talk about water. So water is made up of hydrogen and oxygen now. It is a mixture of two things, right? Getting it? Water can be broken down now. If you were to pass electricity through it, it can break into hydrogen and oxygen. You know, liquid hydrogen is used as a fuel now. It's a very good fuel. Where do we get hydrogen from? Huh? Do we get it from the air directly? No. We basically split water. This is water. H2 is the formula of water. Everyone knows, I suppose. When we pass electricity through this, so thereby it is broken down into hydrogen and oxygen. So it is not the simplest substance. Why? Because it is made up of two substances here. It can be broken down into hydrogen and oxygen. But when I talk about the element, I have taken an example of element like iron element. So it's going to be the simplest substance. They themselves are the simplest substance that cannot be broken down via simple methods. Okay, na? Got it? So we have so many examples of element. As you can see here in this table, we use the symbol for representation of different elements rather than writing the whole name. If you were to write down the whole name, it will become so big in size, right? So we have got short symbols like the first letter of the name of the element or the first two letters, or Greek or like Latin name of the element is written here. Like iron, we know, we have heard of iron, right? But we haven't heard about the ferrous. In Latin, in Latin, iron is called as ferrous. So instead of writing the symbol of iron as IR, since in Latin it is called as ferrous or ferric, ferric basically, ferrous, ferric, or like particularly to be very specific, it is ferrum. So we use the first two letters of the word here. Nonetheless, the basic thing we need to understand that all of these are different elements here. Like we have hydrogen, helium, this is lithium, this is beryllium, this is boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. In total, there are more than 120 elements which we have as of today. Getting it, guys? So these are some of the elements. All of them are having separate symbols, and no two elements can have the same symbol. Can you find any two element in this that are having the same symbol? Try to find. Try to find. Is there any? Obviously, no. Right? That is one thing. Take a look at the different symbols also. Can you guys tell me which one is the symbol of hydrogen? Top left corner or top right corner?
Top left.
Top left corner.
That is the hydrogen, right? Okay. As you go into the senior classes, you will learn a little bit more about the different elements. Okay. That is one thing. Further, now we can say that we have little bit idea about the element now. So is element is the simplest substance which cannot be broken down into two or more simpler substance by chemical reactions. You guys write down the chapter name and write down a definition for element quickly. Write down chapter name and write down the definition for element. So by chemical reactions, what kind of chemical reactions? It could be like by applying heat.
Applying heat, light, and electrical energy.
Very good. Heat, light, or electricity. So that is it. Okay. There are many examples like hydrogen. Helium is an example. Lithium, carbon, nitrogen, etc. You all must memorize the names of elements up to 20. Minimum 20. Maximum you can memorize it up to 100, but that won't be of much use. So from hydrogen till calcium, one should actually memorize the names. Okay, that is one thing. Further, all elements are represented by symbols which are unique to each one. Which are unique to each one. Like it's not same. The symbols of two elements cannot be same. Write down this much fast, and also understand about one more thing. That is going to be atom. So the smallest particle of an element, that is simply going to be an atom. That is going to be an atom. Getting it? No? So suppose I have iron element in my hand. Okay, I have something in my hand. Let us suppose that I have a iron spoon in my hand. Let us just suppose this is the iron spoon in my hand. Okay. So the smallest particle of this iron spoon, that is simply going to be called as atom. Getting it, Pawan and Gauss? And that you cannot see with your bare eyes, obviously. You need to take the help of electron microscope. A very highly magnified microscope has to be taken help of. Okay. So next thing, should I change the slide? Yes. Write it down first if you haven't. Okay. So element we can say it's a substance which is made up of only one kind of atom. We can say that also. The smallest particle of an element is called as atom, right? And a sample of an element contains only one kind of atom. Like this is an iron element, so it will have atoms of iron only. It will not have atoms of copper or other thing in it. So that gives another definition of element also. So we can write one more thing, that an element, do not draw this. Okay, now this was do not draw this. Let me erase this. So we can write one more thing, that an element is a substance which is made up of, of only one kind of atom. Okay. And there are as many types of atoms as elements are. If there are 120 elements, so there are 120 types of atoms. Getting it? So there are as many type of atoms as are elements. So different elements are made up of different kind of atoms. Like sulfur element is made up of only sulfur atoms, whereas if you have iron element, it is made up of iron atoms only. So the atom of different elements are different from one another, right? That is one thing. Also, suppose if I take a given metallic object, let us say iron. Now, iron can be in the liquid state, can be in the solid state as well. Let us say. Uh, so the atom of the element will remain unaffected by the physical change in the atom. Let's say, for example, you have an atom of the liquid sulfur in the liquid state, or you have sulfur in the vapor state, in the gaseous state. So both of the atoms of both of these will be exactly the same as that of the solid sulfur. Last thing is clear, like what I just said to you guys. I just said now. Let's suppose I have solid sulfur. Sulfur is usually yellow in color. Okay. Or either I have sulfur in the gaseous state. Okay. Or I have sulfur in the molten state. Let us suppose. This is solid sulfur. This is vapors of sulfur, and here we have molten sulfur, meaning that we have sulfur in the liquid state. So irrespective of the physical state of the given element, the atoms are going to be same. They are going to remain unaffected by the physical change in the element. Got it or not what I'm trying to say? Okay. Tell me if it is clear or not.
Yes, sir.
Pawan, you also getting it?
Yes.
We can write one more statement that atoms of elements remains unaffected, remains remains unaffected, um, remains unaffected due to this. Atoms of elements remains unaffected irrespective of the physical state of the elements. Physical state of the elements. All right. One more thing I did told you moments ago that if they are 120 elements, so they are 120 atoms as well. Like one types I'm saying, not like in total they are 120. Okay. Now, like how many of these atoms are occurring naturally? Like it's not like all of them are occurring naturally. Obviously, some of them has been made in the laboratory also. Okay, na? So right now, like they are somewhere around 92 naturally occurring elements which we have. Okay, now we have about 92 naturally occurring elements. So out of these, total 92 are found in the nature, right? While the others have been manufactured in the laboratory. So next point, write down that 92 elements are naturally, or rather we should write it in the following manner that they are 92 naturally occurring elements. Okay. And while a lot number of elements are made in the laboratory, and like recently so many elements have been made in the laboratory. Okay, now so many of them have been made in the laboratory. So in total, if you were to see that, like particularly somewhere around 20 to 30, 20 to 30 or more than that number of elements have been made in the laboratory. Okay. So that was about the basics of elements. Hope you guys have got it so far. All right. Any questions from these?
No, sir.
If not, let's continue with the main thing, that is about the metals and non-metals, right? In this periodic table, the ones that have been marked in the blue color, they are the metals, and the ones in the yellow color, they are the non-metals. Other than metals and non-metals, we have one more categorization, that is of metalloids. That is of metalloids. Like for example, take a look at some of them. Like take the example of like silicon. Huh? Where is silicon? This is the silicon over here. Silicon, boron. Huh? We have the example of germanium. We have example of arsenic. Arsenic. We also have the example of antimony as well. So these are some of the elements that have the properties that lies between metals and non-metals. Getting what I'm trying to say? In addition to metals and non-metals, we have one more type of element, that is basically the third category of element we're having called as metalloids. Metalloids. So in metalloids, we have the examples like boron, silicon, germanium. Germanium is there. We also have examples of arsenic, antimony. arsenic, antimony. So these are the examples of metalloids. So the thing about the metalloids is now that they have the property lying between metals and non-metals. Getting what I'm trying to say? This is antimony. This is antimony. This is tellurium, by the way. Okay, no? Yeah. So their properties existing between metals and non-metals. You must have heard about the use of germanium or silicon, right? They're quite expensive. They are widely used materials. They are used in making of chips also, particularly silicon is used in making of computer chips, right? These metalloids are also used in the manufacturing of solar panels as well. So that is the thing. First, let's talk about the metals. Metals are described as chemical elements that loses their electrons to form positive ions. In general, basically these are the elements that are hard, that are basically hard. Okay, they are malleable, they are ductile, they are good conductors of heat and electricity. But what I have written here, let us understand this. Like, what does this term mean basically? As you guys already know, every element is made up of atoms, right or no? When we take a look at the structure of the atom, in the center, we have got two subatomic particles. In the center of every atom, you will have two particles. One is called as proton, another is called as neutron. And both of them are found inside the nucleus. Okay, now they are found inside the nucleus of the atom. As for another particle that is called as electron, so it is found in the orbit of the atom. This is called as the, we can call this as the orbit of the atom in which the electrons are found. Electrons are found. P here is for proton, and here is for neutron. E here is for electron. P here is for proton. Proton
Sir,
has got, yeah,
sir, the proton and neutron form the nucleus, right?
yeah, they forms the nucleus.
Okay, sir.
Hmm. So proton have got zero charge on it. Sorry, I mean to say neutron actually. The neutron has got zero charge, proton has plus charge, and the electron has negative charge on it. These are the basic things that one should know. Okay, electron negative charge, proton positive, while neutron zero charge. It does not have any charge on it. Then the number of proton and neutron always remains fixed in the atom. It is not going to increase or decrease. They are tightly fixed to the nucleus. As for the electron, it can go from one atom to another atom. Getting it? It can go between one atom to another. Like if this is atom number one, and right next to it we have another atom, let us say this one. So these two atoms can actually exchange their, not exchange, I mean to say, particularly the electron can go from atom number one to atom number two. Okay, can go from atom number one to atom number two. So suppose earlier, right now, suppose there are 5 protons in this. Just take a hypothetical number. Okay, and I'm taking just a hypothetical number. So just take that 5 protons are there, and the electrons are also 5. 5 electrons are there. So when the number of proton and electron are same, so it means that the atom is in a neutral state. Is in a neutral state. Pawan and Gauss, you guys understood this thing which I have said?
Yes, sir.
It's a basic thing. Try to memorize this. It's going to help you in your higher classes. So proton and electron are always equal to one another. Also, I can say that 5 protons are there means 5 charges now. Can I write 5 charges? 5 electrons means 5 negative charges. Yes or no?
Yes, sir.
because one proton has one positive charge, one electron has one negative charge. So right now it is in a neutral state. But especially if this atom happens to be a metal, if this is a metal now, then you know what it will do the outermost electron, like it's not only having one electron, it can have more than one electron also. Like here it has five electrons. Okay, so what it will do now, if we lose the outermost electron, whatever number of electrons will be present in its outermost orbit, like there can be multiple orbits here, like say that this is the nucleus of an atom, proton plus neutron. It can have multiple orbits like this, one, two, three, like this. Getting it? So it can lose the electron present in the outermost orbit, and that electron present in the outermost orbit is what basically we call as valence electron. You don't necessarily to memorize this, but just know the basic thing that all the metals particularly, what they do, they lose the electron present in their outermost orbit. And if they lose it, what is going to happen now? Earlier it was 5 plus and 5 minus, now it's going to be 5 plus and 4 minus. So it has now an extra positive charge or no?
Yes, sir.
Right? So metals loses the outermost electron and they become positive. They become positively charged particles called as ions particularly. We have this term ions in this chapter, like in the upcoming classes. Ions are basically we charged particles. Earlier this atom was in a neutral condition, but now it has lost one electron. So thereby it became positively charged. Understood this thing? Tell me if it is confusing or you guys have just got a little bit of idea about or not. To sum it up, let me just tell you one line thing. Basically, the metals, they will lose some of the electron. If they lose electrons, they are going to become positive charge particles. That much is clear to understood. That much should be understood. Okay.
Yes, sir.
Yes, sir.
As of now, just understood this much. Okay. Some examples of metals are like aluminum, copper, iron, tin, gold, etc. Around 90 of the total 118 elements are metals. Okay, na? We have got although more than 180 18 plus elements are there. Okay, so about 90 of them are metals. Further, we are going to discuss about the properties of the metals, right? Okay, so that is the thing. So the most important properties of the metals are that they are like malleable, they are ductile, they are good conductors of heat and electricity. Most of the metals are lustrous, they have a shine on them. They are usually hard and strong, they cannot be easily cut. All the metals are solid except for mercury. Mercury, which was used in the clinical thermometers, the glass clinical thermometer, that is in the liquid state, but it is a metal actually, it's a liquid metal. Now, if you have to heat the metal, if you have to melt it, if you have to boil it, so tremendous amount of heat needs to be provided to it because their melting point and the boiling point is very, very high. Uh, can you easily melt iron? Huh? Will you be able to melt the iron or boil the iron easily?
No, sir.
Obviously, no, because they have got very high melting and boiling point. So tremendous amount of heat needs to be given to them. Also, have you seen like the metals objects usually float in the water? Suppose if you have a brick made up of iron, will it be floating in the water? Will it sink to the bottom?
It will sink to the bottom.
Obviously, because metals usually have high density, right? No? So metals are known to have high density also. Okay, they have high density. Plus, when you strike the metal, it produces a ringing sound. No? The metals are sonorous, means that when they are hit, they give a ringing sound. So let us learn about the physical property of the metals. First, quickly read the given paragraph.
Metals are malleable and ductile. Metals are good conductors of heat and electricity. Metals are lustrous and can shiny and can be polished. Metals are solids at room temperature except mercury, which is liquid. Metals are tough and strong.
Okay, good. Let's talk about each of the properties first, one by one. First, talking about the malleability. So, malleability basically means that the metals can be heated. After being heated, they can be beaten into thin sheets with a piece of hammer or some other object. So, if you have, suppose, taken a piece of aluminum metal or gold, right? You place it on a block of iron and beat it with a hammer. So we will find that the piece of aluminum metal or the gold turns into a thin aluminum or the gold sheet without even breaking, right? So we can say that the metals like aluminum or gold is malleable. It shows malleability. So the property which allows the metals to be hammered into thin sheet is what is called as malleability. It's a very important characteristics of the metal, right? Most of the metals are malleable. In fact, gold and silver, they are the most malleable metal which we have. Gold and silver are the most malleable metal which we have.
Sir, is aluminum also malleable?
Yeah, aluminum is also malleable, right? I quoted the example. That's why I quoted the example. So aluminum is also malleable. Okay, we have aluminum foil. Aluminum foil is used now, right? It is used for packaging the food. Although
Yes, sir.
using aluminum foil for packaging the food is not a very good thing. Okay, no, we should not be using it because there's a risk that the aluminum foil can react with the liquid. Especially, one should not store acidic food or food in which high amount of salt has been added, because aluminum can react with it, and there's a concern that it can lead to some food poisoning or can alter the taste also. Okay, no? So that is the thing. Like it can react with the food. There are some health concerns also related with this. Okay, so that is the thing. So malleability, it also yeah. So I was saying that it is due to the property of malleability that metals can be bent to form objects of different shapes by beating with a hammer. Okay, now it is because of the property of malleability of iron that an iron smith can change the shape of a block of iron block of iron metal by hammering it into different iron objects. Like he can make an axe, he can make a spade or a shovel or a sword. If you were to provide just a block of iron metal to a iron smith, by heating and continuous hammering, he can convert this into a sword, into a spade, or into a shovel, etc. So that is the thing. In comparison to metals, if you were to talk about the non-metals, suppose if I were to give you a piece of wood and I ask you to convert that into a sheet, will you be able to convert it? Obviously, it would be difficult. You can't convert a piece of wood into a sheet now,
Yes, sir.
right?
Because it is a non.
Exactly, it is non-metal, and non-metals are usually brittle. Means that when they are hammered, they break into smaller pieces, right? That is something. Okay.
Yes, sir.
So that was about the property of malleability which we have learned. A special thing to be learned in context of malleability is about the carbon. Carbon is a non-metal. When you look at it in the periodic table, you will find it in the other part over here. You can find that this is where the carbon is. It's a non-metal. The thing about the carbon is that though being non-metal, non-metal generally are weak, they are brittle, they don't produce sound. But carbon can be found in many forms. Like charcoal, it's a form of carbon. Coke, carbon. Graphite, also carbon. Diamond is also a form of carbon. You guys know about this, right? So these are the different forms of carbon. The pencil lead is a form of carbon called as graphite. If we take a piece of carbon, let's say we have taken a pencil lead or we have taken charcoal and we beat it with a hammer, it will break into pieces, obviously, right? We can not hammer carbon without breaking to obtain this thin sheets of carbon, right? So carbon is a non-metal which is not malleable. Carbon is rather brittle. On the other hand, like we have sulfur also. Take a look at the sulfur. This yellow powder that you're seeing, this thing over here, that is the sulfur. It is also brittle in nature. Okay, now if you were to try to hammer, it will break into smaller pieces. So we cannot hammer sulfur to obtain thin sheets of sulfur. So thus we can see that sulfur is a non-metal, which is not malleable. It is rather brittle. Okay. So this word brittle I have been using for some time. So I'm saying that the property due to which non-metals break on hammering is called as brittleness. What do we call that? Brittleness,
Brittleness.
we should be learning particularly in the case of non-metals. So non-metals are showing the property of brittleness. After malleability, we have the property of metal, like we have ductility. So ductility means that, like we say that metals are ductile. So this means that metals can be drawn or stretched into thin wires. In fact, most of the metals are ductile, particularly gold and silver are the most ductile among all the metals. Even gold and silver were the most malleable also. Other than gold and silver, copper and aluminum metals also have also show high ductility, right? And can be drawn into copper wire and aluminum wire. All right. So that's it.